often GCSE papers kind of have sort of similar questions, but now and again, like maybe one a paper or maybe one or two across the three papers, they just chuck out something that's quite different. And I think this falls into that category. Especially the last bit, an algebraic proof, question 14, and I think it's a bit different than talking about consecutive numbers and prove this with square numbers and so forth. In any case, let's have a go at this. So the first question is just kind of guiding us a little bit. So m is 35. We're going to get that L is equal to the product of the left and the right numbers. So it's going to be 34 times 36, which we'll work out in a minute. That was a really bad 6. And t is the product of the top and bottom, so for us it's going to be t equals 25 times 45. Okay, let's work these out. So we get 1224 and 1125. Therefore, L minus T will equal, I can see immediately from this, it's going to be 99, and that'll be enough working. But prove that for any position of the cross on the number grid above, that L minus T equals 99. So that's going to be a slightly harder thing. So we need to maybe work algebraic, well, I don't maybe need to, we need to work algebraically for this. So basically I can't just pick every single, I suppose I could pick, in this case it's not an infinite grid, so I could pick every single number in turn and deal with it, but that's not how we want to do it mathematically. We want to prove it. So let's instead say that our number is x and then write out how the numbers compare in these other spaces. So the one to the right is always one more. So it would be x plus 1. And this is our algebraic proof that we're doing. And then to the left, it would be x minus 1. I know I'm running out of space. I've not made my grid big enough, but you get the idea. And then we can see as you go down, you're increasing by 10. And as you go up, you're decreasing by 10. And that's the same throughout the whole grid. So I can put x plus 10 here, and I can do x minus 10 here. And we're on our way, because then L is going to be x minus 1 times x plus 1, multiplying those two together, and t is going to be x minus 10 times x plus 10. Now these are actually special double brackets, because when we multiply it out, let's do it carefully, x squared plus x, but then we're going to get a minus x, I'm going to get a minus 1. And what this is a difference of two squares. And this is something actually you should learn to recognize, that the fact that if you have an x and a minus and a plus are the same thing, then you'll just get x squared minus 1. And similarly here, we're going to get x squared minus 100, because the minus 10x and the plus 10x will cancel, and we'll be left with x squared minus 10 squared, which is 100. So that's enough working. And then we're nearly there. L minus t will equal x squared minus 1 minus, we need a bracket around the whole thing because I'm minusing the whole thing here. So when I expand this out, it will become minus x squared, but then there's a double negative, and I'll get a plus 100. These cancel, and that's going to cancel, and then that's going to leave me 99. And that is my algebraic proof as required. I might just add at the end. I hope that makes sense. That's not easy, especially if you've never seen that before, but practice algebraic proof, and then it's about relating, it's about always starting with something like x or n and relating the other numbers to it, and then applying some mathematical operations, often expanding brackets in these GCSE papers at least.